6th grade, Module 5, Lesson 11, Classwork. Opening exercise. Which prism holds 1 inch by 1 inch by 1 inch, holds more 1 inch by 1 inch by 1 inch cubes? How many more cubes does the prism hold? Okay, so if we had 1 inch by 1 inch by 1 inch cubes, then we're just finding the volume of 10. Remember, volume is equal to length times width times height. So 10 inches times 4 inches times 6 inches. So 4 times 6 is 24, so 10 inches times 24 inches would be equal to 240 inches cubed. So the volume of that one, we could fit 240 square cubes in that were 1 inch by 1 inch by 1 inch into that prism. This other one, we have 8 inches by 5 inches by 12 inches. So 8 times 5 is 40 inches squared times 12 inches would be equal to 4 times 12 is 36. 40 times 12 would be 360 inches cubed. So, which prism holds more? So this one holds more. Because 360 is larger than 240. How many more? Well, 360 minus 240 will give us 120 more cubes is what it would hold. 120 more cubes. Example 1. A box with the same dimensions as the prism in the opening exercise is used to ship miniature dice whose side lengths have been cut in half. The dice are a ½ inch by ½ inch by ½ inch cubes. How many dice of this size can fit in the box? Okay, so I feel like this is easier to see with a picture, but I'm not a great artist, so I'm going to draw what it would look like if we just filled them with 1 inch cubes. So if we just filled it, pretend that's a cube, okay. So if we just filled it with 1 inch by 1 inch by 1 inch cubes, it would look like this, like what we did up here. So we just filled it with this one with 240 of those, and the second one, there were 360 of these little cubes could fit in there. But now the dimensions are ½ by ½ by ½. So each, instead of 1, it's a half, but by a half by a half. So you can see when all of the side lengths are a half, we can count a 1, there's 1, 2, 3, 4, and in the back 5, 6, 7, and there's one hiding back there, 8 cubes. So there's 8 cubes in 1 cubic unit when the dimensions are cut into half. So we want to know how many dice of this size can fit in the box. Well, if it's 10 by 4 by 6, before it was 240 inches cubed, and we could fit 240. But now, in 1 cube, one of the 1 cubic units, we can fit 8. So we can multiply that by 8 and see how many cubes would actually be able to fit in there. So let's do 240 times 8. We get 1,920 ½ inch by ½ inch by ½ inch cubes would fit inside this box or rectangular prism. Another way you could have done it, so if that didn't quite make sense to you, notice that this is 2 halves, so this basically just doubled. So there are 2 ½ inch sections to get us to 1. So I could just double this and make it 20. And then I could double this and make it 8 because there's going to be 8 little halves in here, or 8 little halves. Or here, double that and make it 12 because we could fit 12 little halves all the way up. And 20 times 8 times 12 should get you 1,920. So there's another method to solving that. Example 2. A 1/4 inch cube was used to fill the prism. So this time, a 1/4 inch cube. So 1/4 by 1/4 by 1/4. How many 1/4 inch cubes does it take to fill the prism? What's the volume of the prism? How is the number of cubes related to the volume? So this time, let me try and draw a nice prism. This time, I'm drawing it big so that we can see it. It's a 1/4 inch by a 1/4 inch by a 1/4 inch. So each of these are a 1/4 inch all the way around. So draw it up the side, and then these are going to be a 1/4, fourths. So 1 cubic unit would hold this many cubes, which would be, if we counted them all, like in this front row, that's 4 by 4, so there's 16. And then the next row behind it would have 16 and 16, so that would be 64 cubes in 1 cubic unit. So how many 1/4 cubes does it take to fill the prism? Well, there are multiple ways that we could do this. We could take this, so we have 1.5 inch by 1 inch by 3 3/4 inch. We can take the 1.5 inch. How many fourths are in 1.5 inch? That would be 6. 6/4, because 6/4 is equal to 1.5. In 1 inch, that would be 4. And in 3 3/4 inch, how many fourths are in that? Let's see, 3 times 4 is 12, plus 3, that would be 15 fourths, so this would be 15. So we can do 6 times 4 times 15, and let's see what we get. Let's see, 4 times 15 is 60, and 6 times 60 is 360. So we would be able to fit 360 cubes in the prism. I hope that made sense. What is the volume of the prism? So if we just want to know the volume of the prism, what we could do is take those 360 cubes and multiply it by what we just did is we did 1/4 times 1/4 times 1/4, which was 1/64. So that's the volume of each one of those little rectangular prism cubes that are in there. Each one has a volume of 1/64 inches cubed. So we can take the 360 and multiply it by, let's do 360 times 1/64. We get 360 over 64, and if we divide that out, let's do 360 divided by 64. 64 can't go into 3 or 36. It could go into, let's see, 6 times 60 would be 360. So probably 64 times 5. Yeah, it can go in 5 times. That's 320. So 5 and 40 64ths. I'm just going to leave it as a fraction because we're working with fractions, but we can reduce 40 64ths. See, we can divide them both by 4. We get 10 16ths, and I can keep going. I can divide them both by 2. 5/8. So 5 and 5/8 inches cubed would be my volume. How is the number of cubes related to the volume? So the number of cubes, the volume is equal to the number of cubes times the volume of 1 cube. So since the volume of this, we were doing 1/4 inch cubes. So let's say, I'll write in a different color. Say the volume is equal to the number of cubes times the volume of 1 cube. So here, the volume of 1 cube, so 1 cube here is equal to 1/4 inch times 1/4 inch times 1/4 inch, which was 1/64 inch, not 1/16, 1/64 inch cubed. So 360 cubes times 1/64 inch cubed got me 5 5/8 inches cubed. That's kind of what we just worked through. So I wrote out what we worked through in the problem. Okay, number 1. Use the prism to answer the following questions. Calculate the volume. So let's start by calculating the volume of 5 1/3 and 2/3 times 1 1/3. So 5 1/3 times 1 2/3 times 1 1/3. I'm going to make them all improper fractions. 5 1/3 is equal to 16/3 times 2/3 is already, and 1 1/3 is 4/3. So now we can multiply. 3 times 3 times 3 is 27. 16 times 2 is 32. And 32 times 4 is 128. So we get 128 27ths. But let's make that into a mixed number. So 128 divided by 27. 27 can't go into 1 or 12. 27 is pretty close to 25. So 25 could go into 128 5 times. So let's try 4. Because 27 is a little bit bigger. 8. 108. So we're only 20 off. If I added another 27, it'd be too big. So it goes in 4 times, and that's 108. We get a remainder of 20. So 4 and 20, 27ths. And that can't be reduced. So it's equal to 4 and 20, 27ths centimeters cubed is the volume. B, if you have to fill the prism with cubes whose side lengths are less than 1 centimeter, what size would be best? I'm looking at, they're all fractions and they're all in thirds. So I would use thirds. So 1/3 centimeter would work best. How many cubes would fit in the prism? So, multiple ways to do this. If we were to, let me draw another image. So if you're having trouble still visualizing this. So it's saying we have third side lengths now. So each of them are a third. So there's 9 in the front, 9 in the middle, and 9 in the back. So we have 27 mini cubes in 1 cubic unit. So how many cubes would fit in the prism? We can do 27 times 4 and 20 27ths, but that's not really a problem I want to do. It doesn't look very fun to solve. So I'm going to take these and break it into thirds. And 5 1/3 is 16/3, so there would be 16 cubes I could fit across there. 2/3, that would be 2. And 1 1/3, that would be 4 of the third. So you can also just do 16 times 2 times 4, and 16 times 2 times 4 would get us 128 cubes. So 128 cubes would fit in this prism that were 1/3 by 1/3 by 1/3. You'll also get 128 if you solve this problem. So 2 different ways to do it. Use the relationship between the number of cubes and the volume to prove that your volume calculation is correct. Okay, so let's say the volume of 1 cube would be 1/3 centimeter times 1/3 centimeter times 1/3 centimeter equals 1/27 centimeters cubed. Since there are 128 cubes, the volume would be 128 times 1/27 centimeters cubed, which would be 128 over 27, and we've already solved. 128 divided by 27 was 4 27 centimeters cubed. So that's how it all kind of works together. Number 2, calculate the volume of the following rectangular prisms. Okay, so remember, volume is equal to length times width times height. So 2 3/4 times a half times 1 1/4. I'm going to make them improper fractions. So 2 3/4 is 8, 9, 10, 11/4 times 1 1/4 is 5/4 times 1/2 is 2/4. So 11 times 5 is 55, times 2 is 110, and 4 times 4 times 4 is 64. 110 64ths. We need to make that an improper fraction, but first I know I can divide them both by 2 over 2, so I'm going to just go ahead and do some reducing. 64 divided by 2 is 32. Not sure what those two have in common, so let's make it an improper fraction. So 55 can go into 32 once, and 55 minus 32, how much are we going to have left over? 23 32nds, and it was centimeters cubed. So the volume of that is 1 23 32nds centimeters cubed. So B, we have 5 2/3 inches times 3 1/3 inches times 3 1/3 inches. I'll make them improper fractions. 5 times 3 is 15, plus 2 is 17/3, times 3 1/3 would be 10/3, and then another 3 3/3 is 10/3. So 17 times 10 is 170, times 10 would be 1,700, over 3 times 3 is 9, times 3 is 27. Let's do 1,700 divided by 27. How many times can 27 go into 170? I don't know. Let's try 6 or 7. 7 times 7 is 49. 7 times 2 is 14, plus 4 is 189. So that's too big. I'm going to subtract 27. So I'll have 6 groups instead of 7. 162. So it can go in, this was 6 times. So minus 162. 170 minus 162 is 8. Bring down the 0. How many times can 27 go into 80? Probably 2 or 3. I think 27 times 3 is 81. So it's going to be too big. But 27 times 2 is 54. So it goes in 2 times. 80 minus 54 is 26. So we get 62 and 26 27ths. Inches cubed as the volume for this rectangular prism. Number 3, a toy company is packaging its toys to be shipped. Each small toy is placed inside a cube-shaped box with side lengths of 1/2. These smaller boxes are then placed into a larger box with dimensions of 12 inches by 4.5 inches by 3.5 inches. What is the greatest number of small toy boxes that can be packed into the larger box for shipping? Okay, so if they're 1/2 length inches, 1/2 by 1/2 by 1/2, that means that for each inch we can fit 2 inside. So I'm just going to multiply all of these times 2. I'm going to double it because 2 halves can fit in a hole. So 24 times 4.5 times 2 would be 9, times 3.5 times 2 would be 7. So 24 times 9 times 7. Let's see, 24 times 9. 4 times 9 is 36. 9 times 2 is 18, plus 3 is 21. 216 times 7 is 42. 7 times 1 is 7, plus 4 is 11. 7 times 2 is 14, plus 1 is 15. So 1,512 toys, small toy boxes, can fit. Will be packed into the larger box. B, use the number of small toy boxes that can be shipped in the larger box to help determine the volume of the shipping box. So one small box is equal to 1/2 times 1/2 times 1/2, and it was inches. So that would be equal to 1/8 inches cubed. So each small box is 1/8 inches cubed. So if we have 1,512 of those 1/8 inch cubed boxes, I can multiply it by 1/8 and I'll get the volume of the box. So that would be 1,512 eighths. So let's just divide. Eight goes into 71. 8 times 8, 8 times. 8 goes into 72, 9 times. So we get 189. And this was inches cubed, so 189 inches cubed would be the volume of this 12 by 4.5 by 3.5. Number 4. A rectangular prism with a volume of 8 cubic units is filled with cubes twice. Once with cubes with the side lengths of a half unit, and once with cubes with side lengths of a third unit. A. How many more of the cubes with third unit side lengths than cubes with half unit side lengths are needed to fill the prism? Okay, so when we have half unit side lengths, 1/2 times 1/2 times 1/2, then we can fit, it's 1/8. So each box takes up each little cube takes up an eighth, which means we would have 8 cubes for one in each those, which is what we did all the way back here at the beginning. Let me find my picture, my beautiful drawing, this one. So that's just saying there are 8 cubes in 1/2 by 1/2 by 1/2, whereas in 1/3 by 1/3 by 1/3, this one I drew here, there were 27 cubes. So when we have 1/3 times 1/3 times 1/3, we get 1/27th, which would fit 27 cubes in a 1 cubic unit space. So how many more cubes with third length side lengths than half side lengths are needed to fill the prism? So it has 8 cubic units. So we want to know how many 8 cubic units. If we had 8 whole cubes and 8 cubes fit in each of those, that would be 64 cubes. If we had 8 cubic units times 27 cubes that could fit in each one, 8 times 27, 8 times 2 is 16, plus 5 would be 216 cubes. So this is the half-inch cubes. This is the third-inch cubes. How many more are needed? So 216 minus 64. 21 minus 6 would be 15. So we would need 152 more 1/3 inch cubes side lengths than half inch. B, why does it take more cubes with third unit side lengths to fill the prism than it does with cubes with half unit side lengths? Well, a third is less than a half. So they're much smaller, which means we can fit more inside of the same size box, right? If you have some smaller coins, like say you have pennies, you could fit more pennies inside of something than you could $50 because they're smaller. So let's say the side length is shorter for the cube with a third unit side length so it takes more to fill the prism. So since they are smaller, it takes more to fill it up. Number 5, calculate the volume of the rectangular prism. Show 2 different methods for determining the volume. Okay, so first method, I'm just going to go the traditional route. So 1 1/2 times 3/4 times 4 1/2. So method 1, 1 1/2 meters times 3/4 meters times 4 1/2 meters. I'll make them improper fractions. So 3/2 times 3/4 times 4 1/2 would be 9/2. And 3 times 3 is 9, times 9 is 81. 2 times 4 is 8, times 2 is 16. So let's see, how many times can 16 go into 81? Maybe 16 times 4 is 64. Try 16 times 5 is 80. So it would go in 5 times. That would be, and we'd have 1 left over out of 16. So 5 and 1/16 meters cubed. So there is one way to find the volume. Honestly, my preferred method. Okay, method 2. What we could do is break it down. So I see we have halves, fourths, and halves. So if we were to find a common denominator, per se, for these, it would be 1/4, right? So we could see how many 1/4 by 1/4 by 1/4 cubes could fit in there. So let's fill the prism with 1/4 times 1/4 times 1/4. So we could fit 1/64 meter cubes in there. So each 1 cube section would be 64. So then, if we broke this into fourths, 1 1/2 into fourths would be 6/4. So we could fit 6 there, 6 across there. 3/4 would be 3/4 across there. And if we had 4 1/2, or 4 2/4, that would be 18 fourths. So we could break this into 18 of those. So we would do 6 times 3 times 18. We do 6 times 3 times 18. We would get 324. So it could be filled with 324 1/4 meter side lengths cubes. So then our final step would be to take that 324 and multiply it by our 1/64. We'd get 324 64ths. And if we were to reduce that, it would equal 5 and 1/16 meters cubed. So 2 different ways to do it. Personally, I like method 1, but if the second method makes sense, then go for it.